Straight up vocab today. 4.2a is about different research study vocab. It does not actually have any entries in the notebook. 4.2a is only on the blue paper. 4.2b has some in the notebook and some in this. So just so you know. Okay. First, we have different types of research studies. This first one is called an observational study. And an observational study observes individuals and measures variables of interest, but does not attempt to influence the responses. So it's not really changing anything, changing anybody's behavior. It's just like measuring what currently exists. All surveys are observational studies because you're just asking opinion or asking for something specific in a survey, but you're not actually trying to, unless you've biased your questions, trying to sway their answer one way or the other. Okay, the variable that may help or predict changes in the response variable, that's the explanatory variable. We know that from chapter 3. And same as chapter 3, the explanatory is the x. The variable that measures the outcome then is what? Yeah, response. At least they use consistent vocab through the chapters. That's good news. Okay. You guys might know this one. I know Jake knows this one. Two variables are associated in such a way that their effects on the response variable cannot be distinguished from each other. Remember, the association of murders and ice cream. You guys remember when I talked about murders and ice cream, right? Okay, what was that called? It's called confounding variables. Two variables are associated in ways so that the effects of the response variable cannot be distinguished from each other. Remember, the association of murders and ice cream, weather was the confounding variable. And remember from chapter 3, correlation does not imply causation. So just because two things are associated with each other does not mean that one caused the other one. This is the same thing from chapter 3. On the last question of your chapter 3 test, I was expecting to see one of two things. So for full credit, you could either say that R squared implied that only like 27.7% of the variability of that thing was due to a linear association with that. So everything else was other reasons. Or you could say correlation was not causation. Either of those two were full credit. Deliberately imposes treatments on individuals to measure their responses. That's called an experiment. Okay, any questions about this first section? Do you guys need to like take a walk or something? Anyone? You're okay? Good? Okay, now let's go to the languages of experiments. I bet you guys know some of these. These are the ones I was thinking you would know. This first one is called a placebo. I heard a couple of people say it when I walked around. A harmless treatment that has no active ingredients but is otherwise like other treatments. So I realize that I'm recording right now, but this is just an aside thing about Mrs. Talbot. I've always struggled with the with the existence of spirituality. It's just something that I'm an extremely, I'm a science and math person, so in my brain I like want to believe, and I have all these conflicting arguments in my head. One of them being randomness. But anyway, the placebo effect is one of those things that makes you question higher power existence, because it is true that you can actually heal yourself by taking a placebo. So how else would that be other than, the mystery of the brain? The brain is super cool. So I don't know. I struggle with thinking about that all the time. I find that topic very fascinating. But one of the things that you just can't really explain is, how can the brain heal itself? How can the body heal itself by taking a placebo just from believing? And it's actually real. So placebo effect is real, researched and real. Mr. Knight and I, we debate this all the time. And then I'm like, I can't explain away the placebo effect. It's super cool. Okay, anyway, a specific condition applied to individuals in an experiment could be a combination of different factors. This is called a treatment. Did you guys know that experiments impose treatments on subjects? Did you know that vocab word? Treatment? No? It might be a new one. Okay. The object to which a treatment is randomly assigned, that's called an experimental unit. It could also be called an individual. And subjects are experimental units that are humans. Going to get into some real fun Grey's Anatomy talk here, because there's been lots of these words used in Grey's Anatomy, lots of times. I don't know if anyone watched the Grey's Anatomy. Yeah. Do you know about the Alzheimer's clinical trials that were supposed to be double blind till someone was placed into the treatment group illegally? Not ethical. No idea. It's fine. It's fine. I stopped watching it a few seasons ago because it just there was so many crazy events. I just couldn't keep on with it. Anyway, okay. An explanatory variable that is manipulated and may cause a change in the response variable, that is called a factor. And then the different levels of a factor Okay, you guys know this one. A group that provides a baseline for comparing the effects of treatments. What's it called? Yes, control group. And this group may receive a, but as Mrs. Talbot stated earlier, it actually might help them. Oh, what's the next box? Describes the researched fact that some of the subjects in an experiment will respond favorably to treatment, even if it's inactive. What's that called? Placebo effect. Still a mystery to Mrs. Talbot. Her little brain can't bend her brain around it. Okay. Neither the subjects nor those who interact with them and measure the response variable, know which treatment the subject is receiving. Double blind. You don't even need me. I could take a nap and you could fill out this whole vocab organizer. Either the subject or those who interact with them and measure the response variable know which treatment the subject is receiving. Single blind. Is this what class is this in? Psych. Oh, I know we're in stats right now. That was funny. Okay. That was all of 4.2a, by the way. I know. Okay, 4.2b. 3 fundamentals of experimental design. Experimental units are assigned at random to treatments using a chance process. It helps ensure that the effects of other variables are spread evenly among treatment groups, making it easier to show a true difference in the response variable. This is called random assignment, which was the thing that was violated when what's her name got put into the treatment group, even though she was randomly assigned to the control group. Who was it? What's his name's wife? Robert's wife? The Alzheimer's trials, right? Right, yeah. What's his name? Weber. Chief Weber, that's right. It's been a hot minute. Okay. Keeping other variables constant for all experimental units to help reduce the variability in the response variable. Do you know what that's called? Keeping everything else constant? It's called control. Like control variables. Okay, last one. Repeating each treatment to enough experimental units so that a difference in the effects of the treatments can be distinguished from chance variation. It's called replication in stats. Okay. All right. And we're going to start talking about the 3 types of experiments that the College Board recognizes. So you're going to need to know these. We're going to draw diagrams in here. The first one is called completely randomized design. This is a regular old experiment. Like, it doesn't have anything interesting happen to it. It's just how you would expect a regular old experiment to go. Here's our diagram. We're going to start with some experimental units. Those could be devices, they could be pencils, they could be people, it could be liquids, pieces of amounts of soil, anything that you want to do your experiment on. So if you want to think about it as the word subjects, you can, but we use experimental units because it's not always alive. Okay. Then you're going to do some kind of random assignment. Now, from what you already learned in the chapter, what do you think the 3 different ways of randomly assigning things are that the College Board will recognize? Actually, there's more than 3, but yes. Table D. Okay, I will tell you that we can never use table D for this. You totally could describe random assignment process with table D. I'm not going to do it. I will never do it. You're not going to see me do it. I'm done with table D as far as we're concerned.
So never gonna see.
Okay. Well, probably in your R columns or T columns or test or something. But most of the time, what we'll do is like rand it, like technology. Sometimes you flip a coin though. So think about that too as being a possibility. Like if you have a treatment and a control, you could flip a coin to decide if they were going to get group 1 or group 2. That's an easy way to describe it, but most of the time I'm going to do the graphing calculator rand int stuff. Okay, but anyway, for our general diagram here, it does not just have to be 2 groups. You can have as many groups as you want. This is just a very generic diagram. So you randomly split them into 2 groups. One of the groups gets one treatment, one of the groups gets a different treatment, and then you bring your research back together and compare. Now, question. Let's say that you do use something that's alive. Will one of the groups always be given a placebo? No. What? Sometimes it's unethical to give somebody a placebo. Sometimes the first treatment, if you still want to have a control group, is like an original medication, and then you could have a new medication. You wouldn't want to take heart patients off of their medication and give them a placebo. That would be unethical. It would be a really bad idea. But you could have a control group still where one of them is taking an old medication and one of them is taking a new medication. That will work for a control group. But I just wanted to throw it out there that just because I said control group doesn't mean a placebo has to be involved. It could just be 2 different treatments. Okay, flip the paper over. This one's called a randomized block design. I'm so sorry to upset you with the amount of work we're doing. What? The random assignment of experimental units to treatments is carried out separately in each block. Groups that are known to share a characteristic. Okay, sometimes there is a characteristic that will separate groups. A lot of times it's gender. I don't like to linger on gender too much because, people get sensitive about gender, but there is research that shows that biologically male people have a higher resting heart rate than biologically female people. Let's not get into the politics of gender right now. If you could just go straight to the human body. Research shows that males tend to have a higher resting heart rate than females. It would be really dumb to randomly assign groups that were mixed male and female at that point, because you would just see the variability because of their gender, not a treatment. Do you see what I'm saying? Sometimes you have to split them into blocks first and do 2 little mini experiments. One with one gender, one with the other, or one with age group, one with one age group, one with another. So, or any kind of characteristic. In this case, you would start with experimental units. And you would first separate them into blocks. This process is not random. It's literally, this group shares a certain characteristic, like they're all over 50 years old, and this group shares another characteristic, they're all under 50 years old, something like that, or 50 and under. You know what I'm saying? Like you would split them up on purpose. Okay, then you would conduct two little baby mini completely randomized design experiments, one separately for this block and one separately in front of this block. Then you could compare the results separately. And then at the end, if you wanted to, you could compare the results together. Okay, I'm going to attempt to do a non-politically incorrect example of both of these, because a lot of times when you go talk about gender, people get all uppity. So I'm going to try to go with cars. No one gets offended by the topic of cars. Okay, I'm going with this because my family is car people. My husband's an auto mechanic, and all of our children are car obsessed. So we just bought a new car yesterday. It's a 2013 DRZ, and I don't really feel great about giving a 17-year-old a rear-wheel drive vehicle, but he saved up his own money all through the summer. And what are you gonna say? Anyway, stepmom problems. Okay. Anyway, it's actually a cool car. Although I bought it from some weird guy who painted the wheels like different colors and purple lug nuts on it. But this is something that we can fix. Okay, moving on. Let's say, okay, so let's go back to the completely randomized design one. Okay, so let's picture Mr. Talbot. He's at work. And do you guys know that when you take your car in for like a service, they dump a bunch of crap into the engine that it doesn't need? You pay for this too, just so you know. Car people, we understand that they're like, oh, this conditioner, that conditioner. Okay, so let's pretend that Mr. Talbot, who does, this is not a pretend part, he actually does work at Toyota Vallejo. So let's just pretend that Mr. Talbot is given this experimental new engine conditioner. Okay, okay, you guys got it? Okay, so Mr. Talbot says in a completely randomized design, let's say that 12 cars come in that day for whatever service, whatever 1,000-mile service. So those are his experimental units. Picture the 12 cars, okay? And then he would randomly assign, so he would have them numbered 1 through 12, and he would do some kind of process, flip a coin, or I don't think Mr. Talbot's whipping out a TI-84 in the middle of the Toyota Vallejo shop, but you know, he could. A process where he randomly assigns 6 cars to group 1 and 6 cars to group 2. Does that make sense so far? Okay, and then the group 1 might get the new conditioner, and group 2 might get the old original standard conditioner. And then he, after some period of time, would do something magical that he does with cars to know whether or not that helps. Oh, we could measure their fuel. Okay, so they all get a full tank of gas, and then maybe he would measure their miles per gallon at the end or something like that. Okay, that would be a completely randomized stuff. Are we good? Yep. Okay, now let me contrast that with a randomized block design. Mr. Talbot's going to be so excited. I'll tell him all about this on the way home from work today. Okay. In this case, Mr. Talbot thinks that maybe that conditioner might be better for bigger cars than smaller cars. So he said of the 12 cars that were brought in, let's say 8 of them are regular sedans, smaller type cars, and 4 of them are like SUVs and trucks. You would split them into a small car and a big car block. Notice that they're not equal size because you don't know what they're going to be. It just depends on how many of them were small cars and how many of them were big cars. You got me so far? Because we've got small car and big car. Then you would say, okay, there's 4 trucks or SUVs. You would randomly assign them using the coin or the graphic calculator or whatnot to either get the old or the new conditioner. And then you would do the same thing with these. These would be numbered like 1 through 4, and these would be numbered like 1 through 8 of the cars. And like 4 of those would get the old and 4 of those would get the new. And then you would have the ability to say, oh, that works really well for the big cars, but not so well for the small cars. Instead of just having like them all in the same group together and not being able to tell anything. Do you see what I'm saying? Do you see the difference between block and regular? Okay, last one. So much talking for Mrs. Talbot. Okay, last one is called matched pairs. Design. Two very similar experimental units are paired, and both treatments are given to both experimental units in a random order. Okay, let's talk about what makes pairs. So you'd have to be able to pair things up with a lot of experiments, and we're going to actually do one, I believe, on the block day. You would do the first treatment and then wait a little bit of time and then do the second treatment, and then you could actually measure the difference in your own ability. So what you guys are going to do on the block day is you're going to take my mouse and you're going to see how fast you click on something with your left hand and then see how fast you click on something with your right hand. And it's going to measure the difference in time. And not only that, it's going to be on the screen in front of everyone while you're standing up there clicking. Oh. And guess who is going to be the most entertained by the entire ordeal? That's going to be you. You don't want to miss that day. It's a fun day. It's my hand reaction time experiment. Here's a fun fact for your class. A lot of times twins are paired up to be pairs for. Did any of you watch that documentary about they gave the identical twins 2 different diets to see what they would respond to? That would be a matched pair situation because they have the same DNA. What? We'll see. I'm so excited. I don't think I've ever had twins in stats before. Okay, anyway. So. Yeah. Oh, yeah, I did. I know. I don't know how. What? Oh, yeah, I did. Maybe we could get them to come in and do the hand reaction experiment with us. Oh, that's a twin. Because it's twin and Do you think it's it's just our grade. Oh yeah, the running ones. Okay, so let's talk about this. So how would Mr. Talbot do a match pairs design for his engine? Oh man, he was laughing so hard at me right now. Because I don't even know that there is, I don't even know. I know that he pours stuff in the engine. And he's like, whatever. But, okay, so the 12 cars come in. He would randomly assign 6 of them to get the old conditioner and 6 of them to get the new conditioner. And then he would measure their miles per gallon. And then the next time they came in for service, he would try to get those same 12 cars in. He would switch it. So this car now got the old one, and this car now got the new one. And then he would measure it again, and then subtract and find the difference in miles per gallon between the old and the new. Does that make sense? So a lot of times it's the same experimental unit doing it twice. There was a matched pairs experiment where they had like one type of face lotion on one side of your face and one type of face lotion on the other side of your face. And then they like measured on a scale of 1 to 10, like how glowing your face was. That's a matched pairs experiment because you're doing both treatments. But it doesn't have to just be the same person doing both treatments. It can literally be like twin 1 getting assigned treatment 1 and twin 2 getting assigned treatment 2. And because they're so paired so well, you can subtract their differences from each other. There's another one in the book where they had like a plot of land and they gave one fertilizer to like one bit and then another fertilizer to the other bit. And since there wasn't anything, it wasn't like shade on one side or the other or something, that you could call that match pairs. Anyway, you'll see. You'll see. Okay. I don't know. Oh, you mean together? Well, I have Katie Nichols, but not Kendall. I know, I know. Okay, you guys, we're gonna get as far as this on we can, and then tomorrow we're gonna finish up 4.2b and we'll do my fun hand reaction experiment. So you're gonna have to come in with some bravery tomorrow, some clicking bravery. What? Yeah, clicking thing tomorrow. Well, it looks like I'm doing okay. I don't know what I'm gonna do about that. I was thinking of making the 4.2A1 extra credit. Just because it's like just vocab. I mean, it can't be a lot because it's one assignment and it's an assignment. No, not test points. No, absolutely not. No. No, if you're just gonna get no. I post the solution already. No. Anyway, okay. So what we need to do next, and I'll just do a little bit of this since we're ahead of schedule now, weirdly. We're gonna talk about how to design an experiment, how to do the random assignment piece. So Okay. For table D, there's 4 steps. Okay, so table D, first step, randomly choose a row to start. So I did rand it on the calculator and I did 1 to 35 because my table was row 1 to 35. I don't know what table D is in the book, what the row numbers are, but whatever. Whatever the first row is, whatever the last row is, comma what, because that'll give you one number. 2. Number experimental units using consistent number of digits. Do you guys know what I mean by that? So let's say 12 cars would be 0, 1 to 12. Just using Mr. Talbot again. That's supposed to say bye. Okay, now I have to throw in a note here. You could find yourself doing too much work if you're not smart. Okay, say we were doing Mr. Talbot's experiment and there were 12 cars. Okay, on the table of random digits, okay, wait, let me say this again. We're doing Mr. Talbot's experiment. There's 12 cars. 6 cars are going to get the old conditioner. 6 cars are going to get the new conditioner. How many numbers do I need to find in the table of random digits? 6. All you have to do is fill up the first group, and then all of the remaining ones will be in the second group. You You don't have to find all 12 in there. That would be a lot of work and unnecessary work. You just need to find the first, you need to find enough to fill up the groups until the last group is going to be the remaining ones. So if there's 4 groups, you have to find all the way through the first 3, but then the last group would be the remaining ones. Again, I will never use table D for any of this unless I'm forced to. Like, you know, if like, I don't know, I was held hostage or something, I might use table D, but that's the only way. Okay, this is the last thing. Okay, when you're done writing this, grab your graphing calculator so we can practice seeing what I mean by arranging the number. In the hat method, if you're going back to Mr. Child's experiment, how many would you have to draw out to get group 1? 6. And then would you have to keep drawing? No, all the remaining ones would be a group 2. Do you see what I'm saying? Okay, grab your graphing calculator real quick. Anyone will do. Oh, goodness. Someone's doing math 3 over here. Okay, go to math. Probability. Rand, int, no repeat. So we're gonna do Mr. Talbot's experiment. We're gonna start with car number 1. We want to go to car number 12. And we want all 12 numbers. Okay, there's 2 things I want to say about this before we move on. Okay, so according to my calculator, what is group 1 going to be? The one that gets the old condition listed there. Cars 5, 8, 9, 1, 6, and 2. Does that make sense? Yeah. Okay, then we don't even care what the rest of the numbers are, because those are all going to get the new condition. Okay, however, before we're done, when you do a function on the calculator like this that has that arrow guy on the side, do you see the arrow guy? Yeah. You have to push over if you want to see the rest of the numbers before you hit any other number on the, any other thing on the calculator. This is the only time that you'll be able to scroll. If you hit any other number or anything else, you won't be able to go back up and do it. It's locked now. You see what I'm saying? So you got to be careful when you do that to write it down right away if it's something that you need to write down. Okay, hold on. Last thing. So it looks as though our schedule is screwed up. I did this and this notes today. This particular homework is just vocab. So we're going to call this one extra credit. Yeah. That's good. So if you don't want to do this one, then just take the extra credit and take the 0 on this one. They'll balance each other out. I'm just saying do one or the other, basically. Then you get extra credit. Yeah. Oh, no, no, no. You can have extra days to do this one. Just do this one.
Can we get our test back today?
Yeah.